In section 5.1, we're dealing with the trigonometric identities. So on your formula sheet, we'll first identify the reciprocal identities, which is this first box. Those are like cosine is equal to 1 over secant, etc. The quotient identities, quotient is a product of division, so these are the ones like tangent of theta equals sine of theta over cosine theta. Then we have our Pythagorean identities, which is sine squared theta plus cosine squared theta equals 1, and that comes from the unit circle when we have our x value being cosine, our y value being sine, and our hypotenuse being 1. If we apply the Pythagorean theorem, that's where we get that identity from. And the other two come from dividing through by sine squared theta or cosine squared theta. And lastly, we have our cofunction identities, which are just showing that sine and cosine or cosecant and secant are simply shifts of one another by an angle of pi over 2. Okay, by the end of this lesson, you'll be able to simplify, factor, combine fractions, and do all sorts of operations with trigonometric expressions. So our first example gives us the value of secant of theta equals -3/2, and tangent of theta is greater than 0, and asks us to find the remaining trigonometric functions. So first we'll apply the reciprocal identity, and we know that secant and cosecant are simply reciprocals of one another, so cosine of theta is equal to -2/3. Okay, and then part B says find the value of sine of theta. So here, let's apply our Pythagorean identity, which says that sine squared theta plus cosine squared theta equals 1. So we can plug in for cosine squared theta, and we get -2/3 from part A. We square that, and that's equal to 1. And if we keep simplifying, we get sine squared theta plus 4/9 equal to 1, and then we're going to subtract off 4/9. We get sine squared theta equals 5/9, and then we'll simply take the square root to solve it, and we get sine of theta is equal to plus or minus the square root of 5/3. Now, the question is, we have this plus or minus. So which one is it? Right? Well, for that, let's look at the next slide, which says, let's decide what quadrant the angle is in. So the first information we have is that secant of theta is less than 0. So secant relates to cosine, and cosine is negative in the second and third quadrants. Okay, the next information we have is that tangent of theta is greater than 0. Tangent is y over x, so this means our y and x values are either both positive or both negative, so in quadrants 1 or 3. Now you can see that we have Q3 in common, so theta is in quadrant 3. Therefore, sine of theta has to be the negative value, so negative square root of 5/3. Okay, now find the other 4 trig functions. So we've got sine of theta. I'm just going to rewrite that here. Is negative square root of 5/3. Now we'll get cosecant of theta, which is the reciprocal, so -3/5. We'll rationalize this value, and we get -3/5/5. We already found cosine of theta, which is equal to -2/3. We know secant of theta is -3/2, which was given. So the remaining 2 trig functions would be tangent and cotangent. So we'll find tangent first. Tangent of theta is equal to sine of theta over cosine of theta, which in this case would equal -√5/3 all over -2/3. And we're dividing by a fraction, which means we can multiply by the reciprocal, so -3/2. Our 3's cancel and our negatives cancel out, make a positive, so we're left with square root of 5/2 for tangent. Cotangent of theta is the reciprocal of tangent of theta, So we'll flip it, we get 2 over root 5. And if we rationalize, we get 2 root 5 over 5. All right, our next task is going to be simplifying trig functions. So example 2 says, let's simplify this expression into one single term. So right now we have sine x times cosine squared x minus sine of x. You can see we start from 2 terms. We want to get that down to 1 term. So the first step is notice that we have a sine of x in common. So we're going to factor out that sine of x and see what we're left with. We're left with cosine squared x minus 1. So I'm going to underline this, and let's look at, it looks sort of like 1 minus cosine squared x, which is equal to sine squared x. And that comes from the Pythagorean theorem. But we need to factor out a negative in order to make it look exactly like 1 minus cosine squared x. So we'll take out our negative, multiply that by sine of x, and we're left with 1 minus cosine squared x in our parentheses. That leaves us with negative sine of x times sine squared of x. And in total, that's a negative sine cubed x, which would be a single term, and we're done. So let's just, on the side here, let's recall our notation, which says, in this case, sine to the third of x is equal to sine of x, entire quantity raised to the third power, not equal to sine of x to the third, right? It's not the variable that's to the third, it's that whole quantity sine of x, which is raised to the third power. Now, a very common technique that you'll use when you're simplifying is rewriting all terms in terms of sine and cosine. This is a very popular technique because most of our identities deal with sine and cosine, not all the other trig values, okay? So first, we're going to rewrite secant of x as 1 over cosine of x. That's multiplied by cosine of x. And you can see how easy it is to cancel those out, and we just get 1. Okay? And the next one, tangent of x, is sine of x over cosine of x, multiplied by cosecant x, which is 1 over sine of x. Cancel out our sines, and we're left with 1 over cosine of x. And we want to go one more step further and simplify that using our reciprocal identity to get secant of x. Okay, in our last example, we've got cotangent squared x minus cosecant squared x. So let's go again in terms of sine and cosine. So cotangent would be cosine squared x over sine squared x. And we're subtracting 1 over sine squared x since we're using our reciprocal identity. And this in total is going to give us cosine squared x minus 1 all over sine squared x. And from example 2, I believe it was, we know that's negative 1 times 1 minus cosine squared x, still over sine squared x. And 1 minus cosine squared x by the Pythagorean identity tells us that's equal to sine squared x. We've got negative sine squared x over sine squared x, which is simply negative 1. Okay. Another common technique when we're simplifying trig expressions is by factoring them out. And this will also come into play later on as we start to solve trigonometric expressions, but for now, or equations, but for now we're just simplifying and factoring. So let's recall some common forms of factors that we know what to do with. So a squared minus b squared is a minus b, a plus b, right? This is our difference of squares. A squared plus 2ab plus b squared, you may not recognize it as rapidly as the previous one, but it's a plus b times a plus b, which is just a plus b squared. And very similarly, the next one is a minus b times a minus b. giving you a minus b squared. And the last two, we have sum of cubes and difference of cubes. So these ones we have memorized from earlier, a plus b times a squared minus ab plus b squared. And then the only difference is here we switch the plus and minus sign in the first expression as well as in the second expression. So a squared, a minus b times a squared plus ab plus b squared. All right, and those ones we call sum and difference of cubes because our powers are cubed. Okay, so we'll see how we can apply those to actual problems. Example 6, we're going to factor secant squared x minus 1. So this is like a squared minus b squared. So we're going to let a be secant of x, let b be 1, and we simply get secant x minus 1 times secant of x plus 1. And in this case, that's as far as we can go. There's no other steps that we can take. Now in example 7, we've got 4 tangent squared x plus tangent x minus 3. So this is an example that looks sort of like a quadratic. So let's use u substitution. And let u equal to tangent of x. So this is going to give us 4u squared plus u minus 3. Now we may need the box method for this. We need two numbers that multiply to be 4 times negative 3 is negative 12. We need two numbers that add to be 1. And it turns out that it's a 4 and a negative 3. Okay, so in our box, we're going to get 4u squared in the upper left-hand corner. We're going to get negative 3 in the bottom right. And then we split it up into 4u and negative 3u. And looks like on this top row, we have a 4u in common. And multiplying by that by u, we get u at the top left. And then u, it's going to be plus 1, and 4u minus 3. So we get u plus 1 times 4u minus 3. Now don't forget, we use the substitution u equals tangent of x, so we're going to plug that back in, and our final answer in terms of tangent of x is going to be tangent x plus 1 times 4 tangent x minus 3. So there's our factored form. Now if you're able to factor this without going into u substitution, that's totally fine. It just offers a comfortable way for some people who need the extra support. All right, one more example of factoring. We've got cosecant squared x minus cotangent x minus 3. So to start, let's get these all in terms of one trig function. Okay, so let's rewrite our cosecant squared as using our Pythagorean identity. So we're going to substitute cosecant squared x, which is equal to cotangent squared x plus 1. So this is going to go in up there for our equation. All right, that's going to leave us with cotangent squared x plus 1 minus cotangent x minus 3. And if we combine that, we'll get cotangent squared x minus cotangent of x minus 2. I just combined the 1 and the negative 3. And now we can factor this like, it's kind of like it's a squared minus a minus 2, which would factor as a minus 2 times a plus 1. But instead of a's, we have cotangents. So this is going to give us cotangent of x minus 2 times cotangent of x plus 1. And now we're in factored form. All right, two more tasks. Our next task, task 4, is adding or subtracting trig functions. So often you'll have big expressions where you have multiple rational expressions, and you need to get those down into a single expression. So the best way that we know how to do this is finding a common denominator, right? So in this case, we're going to multiply the left-hand equation by sine of theta over sine of theta. So we have sine theta over 1 plus cosine of theta plus cosine theta over sine of theta. And I'm going to multiply the left-hand side by sine theta over sine theta. And I'm going to multiply the right-hand side by 1 plus cosine theta over 1 plus cosine theta. And let's put that in parentheses because there's two terms. All right, we'll keep simplifying. And we get sine squared theta on the left-hand side over sine theta times 1 plus cosine theta. And that's added to cosine of theta. And let's distribute this in. So cosine theta plus cosine squared theta over sine theta times 1 plus cosine theta. Now we've got a common denominator, which gives us sine squared theta plus cosine squared theta plus cosine of theta. So I flipped the terms in the right fraction so that you can see why we have sine squared plus cosine squared, and we're going to use the Pythagorean identity in our next step to simplify. Okay, so sine squared plus cosine squared theta is 1, so we get 1 plus cosine theta on the top, and we still have sine theta times 1 plus cosine theta on the bottom. You can see that those are the same terms, and we're left with 1 over sine of theta, which is cosecant of theta. So a good reason that we use identities is to take a big, ugly, messy expression, like the start of example 9, and turn it into one simple trig function, cosecant of theta. One more example. We've got 1 over secant x plus 1 minus 1 over secant x minus 1. So again, we want a common denominator. So I'm going to take my left-hand expression and I'm going to multiply that by secant x minus 1. I'm going to multiply my right-hand equation by the denominator from my left hand. So secant x plus 1 over secant x plus 1. And then we'll start distributing everything out. We get secant x minus 1 minus secant x minus 1. And that's all over secant x plus 1 times secant x minus 1. Right, the numerator, we have secant x and we have negative secant x. So those cancel out, and we're simply left with negative 2. And we have secant x plus 1 and secant x minus 1 in the denominator, which is a plus b, a minus b. So I'm actually going to FOIL those out, and I get secant squared x minus 1. And now you should notice that that is a Pythagorean identity, which is exactly equal to tangent squared x. So we've got negative 2 over tangent squared x, which is equal to negative 2 cotangent squared x. So that's our final answer. We got rid of our fractions and we got rid of any addition and subtraction. So we simply have one trig function and we have multiplication, no fractions. All right, our final task for the day is rewriting trig functions into their rational form. Or from rational form into a form that we have no fractions. So we start with 1 over 1 plus sine of x, and we're going to have to use some tricky different ways to get it so it's out of rational form. Now there's many different ways of solving these, and that means that you could have many different answers that you get, but as long as you work through and you work carefully and you get an answer that has no more fractions, then you should be good to go. All right, so let's try this one out. I'm going to start with this 1 over 1 plus sine of x, and I'm going to start by multiplying by 1 minus sine of x on the top and the bottom. So this is sort of like the conjugate, right? A plus bi, a minus bi. So this is sort of the trig form of a conjugate. And the reason I did that is because we're going to get 1 minus sine squared x on the denominator of our fraction. And that is going to turn into cosine squared x, which hopefully we can work with. So we're getting rid of the addition and subtraction in the denominator so we can start to simplify. Okay, so I've got 1 minus sine x over cosine squared x. Let's break this into two separate fractions. So we get 1 over cosine squared x, and then we have minus sine of x over cosine squared x. Okay, and our final step, let's rewrite these using the reciprocal identities, and we get secant squared x minus, I'm going to take a sine x and a cosine x and make that into a tangent of x. And I'm left with a cosine x on the bottom, which would make a secant x on the top. So your final answer is secant squared x minus tangent x times secant x. So we see we're done with our fractions. There's no fractions left over, so our answer should be complete. We could always check it graphically or plugging in some values for x to see if we actually simplified correctly. So that's the end of this lesson. You'll notice at the end of the notes you have some problems that you should try, so go ahead and try those now.